This video is going to review how to do implicit differentiation. And so I've got one equation up here. It's in terms of x and y, and I'm asked to find dy dx. What implicit differentiation allows you to do is to find the derivative of y without actually solving for y. If you were to try to solve this for y and write it explicitly as a function of y, that would be tough to do algebraically. So this just allows me to find the derivative of y as it sits. So I'm going to do this derivative implicitly. And the way that I start is I'm going to do a derivative with respect to x, term by term. So altogether, I've got 1, 2, 3, 4 terms. I'm going to do a derivative with respect to x of each one. So d dx of negative 2y squared plus d dx of 3 equals d dx of 4x squared plus d dx of 3xy. So I've got 4 derivatives to do. Some are easier than others, so just looking at these. This one right here, where I'm just doing the derivative of a constant, that guy's pretty easy. Derivative of a constant is 0, so that's just going to disappear. The derivative with respect to x of something that just has an x, that's just business as usual. So that derivative is simply just going to be 8x. And so now I've got 2 more derivatives to do. So right here, so keep in mind that y is some function of x. So think of y as an inside function, and I'm going to apply the chain rule. So the chain rule says do the derivative of the outside. So my outside function is this negative 2 coefficient, and then the squaring, and y is my inside function. So derivative of the outside is going to bring down that power, and it's going to say negative 4 to the first power. So that was just power rule. So derivative of the outside, leave the inside alone. So my inside function is this y. So I'm going to leave the inside alone. So that's just y. Times derivative of the inside. So now I have to do the derivative of y. And I'm going to use that Leibniz notation, and I'm going to write dy dx. So that was just the chain rule. So derivative of the outside, leave the inside alone, times derivative of the inside. If you see the chain rule in that, great. If you don't, then all you're going to do is look at this. You're going to do regular derivative. So you look at that and you say, oh, negative 4y. But when you have that discrepancy in variable, a y here and an x here, just take that extra step and multiply by dy dx. And that is the chain rule. And then my last derivative over here, I actually have a product. I'm going to treat this, and you can look at it in different ways, but I'm going to treat it as 3x times y. So when I go through my product rule, I'm going to look at that. 3x is my first, and that y is my second. And I'm going to run myself through this product rule. So I'm going to go the first item, which is 3x, times the derivative of y. So again, I'm doing the derivative of y with respect to x. So dy dx, you can just think of it like derivative of y is 1, but that discrepancy in variable makes me stick that dy dx on there. So I'm only halfway through my product rule here. So there's first times derivative of the second plus the second, which is the y, times derivative of the first. Now when I do derivative of 3x with respect to x, all that is simply a 3. And now I've done all my derivatives, and what I need to do now is collect all my dy dx terms. So let me get a feel for my different terms on here. So I've got, this is 1 term, this is 2, this is 3, and this is 4. What separates the terms are the plus signs and the equals. So I've got one term on the left and 3 terms on the right. Every term that has a dy dx needs to go to the same side, and you can choose whichever side you'd like. I'm going to pick this side right here. So here are my distinct terms here. So I'm going to take this term and I'm going to subtract it and move it to the other side. So now I've got negative 4y dy dx minus 3x dy dx. And my two terms that do not have a dy dx, this one and this one, are going to stay put. So they're going to remain on the right side. So equals 8x plus 3y. So now, because of how I separated this and everything on the left side has a dy dx, since they have that common factor, now what I'm going to do is factor it out. So I'm going to factor out dy dx. It's going to leave a negative 4y minus 3x equals 8x plus 3y. And now my last step in solving for this dy dx, it's being multiplied by this factor right here. So I'm just going to divide both sides by negative 4y minus 3x, divide by negative 4y minus 3x, and then that gives me dy dx equals 8x plus 3y over negative 4y minus 3x. And that is my final derivative. Now just be careful when you get to this stage. You're not going to want to try to simplify things. It's a common error to go, oh look, I can divide 4 out of each one of these. It doesn't work like that because they are just parts of a factor and not an entire factor. So your best bet is just don't touch it. Just leave it just like this and all will be well. I hope this helps.